All right, hey guys. Big quiz on Tuesday, last quiz of the quarter. If you have some questions, I'm glad you tuned in. Hopefully by the end of the video, you'll be feeling good to go. But let's do it. Looking here, you're looking at a direct integral. In the last class period, we talked about how to actually just find the antiderivative and use the fundamental theorem of calculus to evaluate this. That is not what we want you to do right now. This is the first homework where we haven't learned that yet. What we want you to do this time is use some of the properties of integrals, like reversing the limits of integration, or like factoring out constants, or like using the adjacent interval property, things like that. Looking at this guy though, there's not a ton we need to do. It says to start at -4. It says to go to -1. That seems to me to just be one smooth chunk of graph. And it's already in order from least to greatest, so I don't need to flip the coordinates. There's nothing to do here except to actually find the answer, so I think that's all they wanted us to do. And so since we don't yet know the fundamental theorem of calculus or how to do antiderivatives, we'll just treat this as a triangle. So we'll go 1/2 times base times height. The base stretches from -4 to 1, so that must be a length of 3. And the height goes from 0 up to 2, so that's a height of 2. And 1/2 of 6 is 3. Since this is an area, it's square units. And that's it on that problem. Let's go to 2. So 2 is a little weird because 2 wants us to go from 2 to 1. And so that's kind of backwards. So before I do any math on this, I will use a property that says we can reverse these limits of integration, but we're now going to get the opposite of what we would have gotten. So if we find the opposite of the integral from 1 to 2 of f of x dx, we know that'll give us the answer to the integral from 2 to 1 of f of x dx. And again, just mark this on the grid. We see that we just have another right triangle here. So again, this total area is just going to be 1/2 times base times height. Our base this time around is only 1, and our height is 3. So that seems to be giving a total area of 3/2 square units. And don't forget the minus. We wanted our area to be negative. So that's a negative area. So in the same way that area under the x-axis was negative, the area that we get from an integral whose limits of integration are sort of backwards, that would be negative area as well. So that was 1b. For c, we've got two properties that we could apply this time. We do want to reverse the limits of integration so that we can go, oh no, that's not true. We want to go from 1 to 5, of course. My brain read that as 5, 1. And I thought we needed to reverse it, but really the only rule we would use here is the one about factoring out this constant factor. So we just pop out a 2, and now we're integrating f of x dx. Now what region is this? Well, we're going from 1 all the way to 5. So we're looking at this whole trapezoid, which of course, if the quiz rolls around and you have no idea what the formula for a trapezoid was, you could break it down here, draw a vertical line, break it down here by drawing another vertical line, and you could do it as two triangles and a rectangle. But I'd like to think we all remember that a trapezoid is just 1/2 times b1 plus b2 times the height. And again, don't forget, we were doing 2 times this function, which means we can just do 2 times the value of our integral. So that means the 2 and the 1/2 cancel. My bases, don't forget, are the parallel sides of the trapezoid. So this top guy up here would be base 1, and he's got a length of 2. The bottom is our base 2, which has a length of 4. And the height of a trapezoid is the distance between the two bases. So for this particular trapezoid, the height is this straight up and down distance here that measures 3 units. So I'm looking at a 6 times 3, which makes 18 square units. So that's 1c. For 1d, again, our limits of integration are fine. We're going from -4 to 5. But if I try to run from -4 all the way to 5, I'm seeing 3 pretty distinct intervals. So I think for this problem, I would want to use the adjacent intervals property, because that's going to allow me to break this down into 3 separate chunks. That's not my best line. But basically, this total integral is of course just going to be the sum of the areas of these three pieces. So to solve this problem, the first thing I'd want to see you do is break this one big integral down to the sum of three integrals. The first integral being the one for this blue region, which would be the integral that goes from -4 to -1 of our function f of x dx. Then the green region is going to be the integral from 1 to 1, -1 to 1 of f of x dx. And lastly, this orange region goes from 1 to 5. And that's all the messing around we need to do. So that blue area, I think we already know it. Wasn't this part A anyway? But I'll just show the math once again. It's 1/2 times base times height, which turned out for us to be 1/2 times 3 times 2. So we just got 3 square units out of that. Then in the middle, the green guy. Now I know I said plus up here, which is right. It is. I do want the sum of all these integrals, but remember that this guy is under the x-axis, so that guy's going to be negative automatically. So this guy's going to want to be -1/2 of pi r squared. And our radius seems to be only 1, so it'll be pi times 1 squared. And that means we're looking at just pi over 2, so it'll be minus pi over 2. And finally the orange bit. The orange bit is that trapezoid that we just did, so it'll be 1/2 b1 b2 times height. And the bases we said were 2 and 4. And the height was only 3. Yep. So the 2 and the 4 make 6. Half of 6 is 3. 3 times 3 is 9. So it looks like we've got an answer that is just the sum of these three areas, which you'd probably want to express as 12 minus pi over 2. And then just leave it in that form. Don't try to simplify it or anything, just leave it alone. All right, what about E? E wants another integral that's kind of going backwards. Notice it's going from 4 to 2. We don't like to move right to left. We only like to move left to right. So I would certainly rewrite this as the integral that goes from 2 to 4 of f of x dx. But of course, when you reverse those limits, you want the opposite now of whatever answer you would have gotten. So 2 to 4 is just this rectangular piece of the trapezoid, which means I can find all this area by just doing base times height and sticking a negative on it. So this will be the opposite of 2 times the height of 3, so just -6 square units. I think that's it for these. No, there's A, B, C, D, E, F. There's one more. We'll do F. F. Okay. So F, first of all, wants us integrating from -4 to 1. So here's -4, here's 1. So they want us to get the area of this right triangle, but they also want the area of this circle. And if I left this alone, if I just left this as f of x, then I'd have a big chunk of positive area, smaller chunk of negative area, and the final answer would be the difference between these two. But we talked about how absolute value bars can affect the graph of a function, and if you're doing the absolute value of f, then anything below the axis immediately gets reflected back up. So that means this guy down here, he's not going to be down there if you're talking about the graph of the absolute value of f of x. And that is what we're talking about. So this negative chunk, all these guys would reflect up. So -1 goes to 1. This guy at negative a little bit goes up to positive a little bit. This guy at negative some goes up to positive something. But we know what we're going to see as a semicircle that's up above the axis instead of down below it. And of course everything else down here is gone. So what's my area now? Well, suddenly now my area would be the sum of those two regions, and that would mean that I do want to rewrite my radical. We'll find this light blue region. It's going to be the integral from -4 to -1. And because this whole region is above the x-axis, I could put the absolute value bars or not. It doesn't matter. I'm just going to put them. Now for the second guy, of course, we're doing the integral from -1 to 1. But we are definitely not integrating f of x. We are definitely integrating the absolute value of f of x. So just make sure you make that notation clear. You could take it away from the blue region, like I said, because everything was above the x-axis anyway. But on this region, from -1 to 1, this stuff should have been negative. So you absolutely must have the absolute value bars here. That's what explains why the area is going to be positive now. Now, I've done this too many times to show the work again. We know this first right triangle is just half of 3 by 2. So he's got an area of 3. And I don't think we've done a circle in a while. Maybe we have. But a semicircle would just be 1/2 pi r squared. So you know you're looking at 3 plus 1/2 pi. And this little circle still has a radius of just 1. So we're looking at 3 plus pi over 2. And in a world where you're not supposed to simplify, that's the best answer right there. Leave it alone. All right, so we're finally through number 1. And we get to 2, 3, 4. Now 2, 3, 4 expects you to actually know how to graph these things, so I'm hoping you can. But looking at this function, for sure I'm working my way out. So this +1 is going to grab my radical function and just want to drag it left 1. So it's like my radical function would be here now, going boop. But of course this negative sign on the outside, that's a negative a value. That would reflect me over the x-axis. So really my radical function is going to be down here. And it's going to be decreasing. So this red guy is the final transformed version of our function. And we're being asked to find the integral from 0 to 3. Okay, easy enough. From 0 to 3 would be that. Sketch a graph and the definite integral. Oh, we're using the graphing calculator, right? Okay. So this should be pretty easy. I've got my calculator handy and everything. So let me just turn that on for you. Somehow. Is it you? Yes. Okay, got it. So anyone who didn't see this in class, I think you all did. I'm pretty sure I got to all of you guys over the course of a couple of days. But the first step, of course, is plug the function into the calculator. So it's negative square root of x plus 1. We can hit graph and make sure that looks how we expected. And it does. My window's bad. I'm just going to zoom 6. And I think that's plenty. Now to calculate the value of an integral, you go to the blue function right above trace and you hit second calc. And you're going to pick the number 7 at the bottom, which literally says integral of f of x dx. So pick 7. It'll ask you for your 2 limits of integration. For this one, you'll just say 0 for the lower and 3 for the upper. It'll even shade the region in nicely for you and tell you that the answer is negative 4.66666666. So that's it. Negative 4.666. 667, we'll say, of course. Now, it should be pretty obvious to you guys that 6666666, that's 2/3. So our answer is probably all 99% sure that it's just negative 4 and 2/3. Is there any way to get any more of the decimals? I don't think so, but it would make sense that we're just getting 2/3 here. So 4.6666666666666. You can always go math frac. Don't forget, convert this to a fraction. And if you really wanted to, you could give me your answer as negative 14/3. That would certainly be better. But when we're using our calculator, I won't really hold you to giving me exact values, I guess. The decimal would be fine. Negative 14/3 though it's just so much better than that. So try to give me the fraction if you can. For number 3, I guess we're just doing it in the calculator. I would certainly expect that you could draw this thing yourself and kind of break it down. So why don't I do that first, actually. I would expect that you guys would remember Well, it's the same actually. We just added 1 and it pulled us left. So now we're adding 1. It's just going to pull us left again. And remember that absolute value is just a v. It's a v where the left hand side, I'm doing the right hand side by the way, the right hand side has a slope of +1 and the left hand side has a slope of -1. So there it is. They want the integral to go from -2 to 3. So if I asked you to rewrite this expression, you may need to do that. So remember, we would certainly break it down at -1, where the graph kind of changes. So I'm going to do the integral from -2 to -1 of this absolute value function. But we said actually the left side of the absolute value function, if you took the bars away, it would be x plus 1. It would be the opposite of x plus 1. So I do kind of want to see you doing that, is getting rid of the absolute value bars, changing the limits of integration, and then going from there. So now this bigger chunk of area is just going to be from -1 all the way to 3. And that's still going to be the absolute value of x plus 1, but on this half we're positive anyway. So if you just take the absolute value bars away, nothing's actually changed. But this is really sort of the integral expression you're more likely to need to write for me and then solve. But again, I know the homework was just saying put it in your calculator and get the answer. So we'll do that. Oh no, did this ever go away? I think it did. All right, anyway, bringing it back. I know I had a few people ask how to actually get to the absolute value. You hit math, this button right here that says math, and it's under the number sub menu. So slide over to number, and the very first guy is ABS. So choose that, and let me make some room. Then just enter the function. So it's x plus 1. I don't even think we need to say graph. I think we can go straight to calc from here, choosing option 7. And our lower limit is -2, so type -2, and then type +3, and we should get that shaded area with an answer. 8.4999 is the answer they're giving. And a number like 8.4999 has me thinking it's probably just round off error, and the answer is probably just 8.5 exactly, but I don't know. Those 9s maybe don't go out enough decimal places. I can't say for sure that it's really supposed to be exactly 8.5, but our calculator does have sort of a built-in error in the algorithm that sometimes makes this happen, where some number along the way got rounded off, and so your final answer is sort of rounded off when it should really just be exactly 8.5. But we'd have to do the math on that to see if that's true, and I don't feel like it because it's not that big a deal. So just put down the 8.499, and that's fine by me, or even 8.500. Anyway, let's do the third one. And I'm not going to go nuts on the third one. Let's just do it in our calculator like it says to. And again, you guys can follow along. You should have done it already. But if you haven't practiced how to do this on your calculator, just make sure you do. All right, but again, the keystrokes were to go into y equals first and enter your function, which will be -x/2. Then we're just adding 1. So that's fine. Yeah, okay, it's just a line. So let's second calc option 7, 1 to -3. Oh, that's backwards. I wonder what'll happen. I've never actually tried this. If we type in 1 and then the -3, I'm betting we get an error. Nah, all right, I'm wrong. So you can enter your limits of integration backwards. You can go from the bigger to the smaller, and it just knows. It knows to say that that answer is negative. So that's pretty cool. That means we're definitely getting -6 as an answer, and it's definitely supposed to be negative, and the calculator did that for us. So if you had to sketch this, by the way, which you probably would, this is just -1/2 as a coefficient on x plus a 1. So this is just y equals mx plus b. So with a y-intercept at 1 and a slope of -1/2, that means we're going down 1 and running to the right by 2, down 1, right 2, or up 1, left 2. But here's 5 points that all live on the graph of our line. We can sketch that in pretty easily. And so where's the area that this integral represents? Well, it's supposed to be the area from 1 to, oops, from 1 to -3. So there's the 1, and here's the -3. And again, our area is kind of building from the right to the left, which means even though it's area that's above the x-axis, we'll treat it as negative. So that's why we got -6. Anyway, oh my, here's a lot of problems. For number 5, just make sure that when you get this kind of question on a quiz, you got to actually rewrite this thing and kind of clean it up. And again, for this one with a constant, the only sort of cleanup you can do is to just factor that 2 out, but show me that step, because that's what I'm looking for. So 2 times the integral of f of x dx. This is technically a new integral that's equivalent to the one we started from. Now 2 to 7, is that on the menu? Sure it is. It's right up here. They're telling us that that whole integral is worth -5. So you're looking at a 2 times a -5. Your final answer is just -10. You don't have to show a ton of work, but you definitely have to show me that you're using the properties correctly. And I didn't turn off the calc. My bad. Anyway, there's the math I was doing. For number 6, I don't see anything special about 6. They've already factored out the 4. The limits go the right way from lesser to greater. And -3 to, it's just sitting right here for us. So basically the only thing they're asking is, do you know that you can just take the 4 and multiply by the whole integral? So 4 times 2 makes 8. Yep, that's it. That's all you do. All right, what about 7? 7 wants to run all the way from -3 to 7, which you might notice that this guy starts at -3 and this guy ends at 7. And these intervals don't overlap at all because this guy stops at 2, this guy starts at 2. So these are adjacent intervals, which means I can definitely solve for the value of this integral by breaking it down into 2 integrals. One that starts at -3 and stops at 2 of f of x dx. And the other integral starts at 2 and goes all the way to 7. And that's f of x dx. And that means that this guy that goes from -3 all the way to 2, that guy's got a value of 2. So we just directly substitute that in for this whole integral expression. And the next one that goes from 2 to 7, that's just the -5. So we can see that this original expression is worth -3. And we can do that calculation by breaking it down to adjacent intervals. All right, what about this one? Well, I can see that I'm going to want to flip these limits of integration. So -3, 2. And that means that this is not really the same as the one we had before, unless we take the opposite of it. And -3 to 2 was handed right to us. That's the guy with the value of 6. So that means this expression, the one that goes backwards through the interval, would just have a value of -6. And for something like 9, we definitely had a rule that said the integral of a difference could just be the difference of 2 integrals. Just break the integral down and let one of them go from -3 to 2 and be evaluating g of x dx. And the other one also goes from -3 to 2 of f of x dx. And now we know that since up here the function was defined to be g minus f, we know that down here would want to subtract the integrals, but this will still give the same area. So g of -3 to 2, that's over here, that's the guy who's worth 6. And -3 to 2 on f of x is this one worth 2. And 6 minus 2 is 4. So that's that. And I think I said I don't super care about these, so I'm not going to care about them. Not going to care. Nah, not going to care. Although I think it's 5. Okay. And then this guy has no absolute value bar, so we'll do this one. But it's got a negative on it already. Then it's got out of whack limits of integration, so I'd change that to 2 to 7. That would generate another negative. and then the negative would just cancel out. So you're just doing the integral from 2 to 7 of f of x dx, and that's waiting for you right here in the middle, saying that it's -5. So I would like to say that's it for these, but I think there's another whole group of these. So we'll push through these, then we're done with the first homework assignment at least. So there's nothing about the integral from 2 to 2 up here in our sort of word bank type thing. But one of our rules for integrals was, of course, you can't integrate from 2 to 2 and expect to get any area, because, well, as we try to integrate some function, if you start at 2 and stop at 2, there's no area there. You're just looking at one line. So this has an area of 0. Just say the number 0. Now this guy wants to go 1 to 6, which means we need the opposite answer. So do we have one that goes from 1 to 6? For G, we do. So it's this 8. So that means our answer is actually -8. Then this guy, well, he's fine. We're just going to do 3 times the integral from 1 to 2. So that's -2. So that's a -6. And this one goes from 2 to 6. Which we can do, because we know that this goes from 1 to 2. No, we can't. What's the matter with me? I'm trying to go from 2 to 6. Huh. Okay. Yeah, my head was getting a little twisted there for some reason, so took a pause, just thought it through, made sure I was getting what I was saying, but I get it now. Hey, wouldn't this integral just be the integral that went from 1 all the way to 6? Just minus the integral that went from 1 to 2? Think of it like this. The integral here that they gave us the value of, that goes from 1 to 6, that's like too big of a slice, right? We only want the slice that goes from 2 to 6. Luckily for us, we happen to know the integral that goes from 1 to 2. It's right here. So if I take that chunk of area away, this is 1, this is 2, this is 6, then if I can take away the integral from 1 to 2, then of course I'm left with the integral that goes from 2 to 6. So that's it. And it doesn't matter if these things are negative. The right rule for sure is to be subtracting. And then if we're subtracting a negative, then technically that'll add. But if the integral from 1 to 6 is 4, and I take away this chunk that's worth -2, then it's like I'm adding them, and I get a total area of 6. And I'm happy with that. That seems to be working. All right, for the next one, we know that this just wants to be the integral from 1 to 6 of f. And then you subtract from that the integral from 1 to 6 of g. And 1 to 6 is easy? Yeah, they gave us 1 to 6. So 1 to 6 is 4. And 1 to 6 on g is 8. And 4 minus 8 is -4. That's it. That's your area. And we can break down 17 the same way. This would break down to be the integral from 1 to 6 of 3f of x dx minus the integral from 1 to 6 of g of x dx. And of course, since there's this constant multiple of 3, we could factor that out. So what we really want is 3 times the integral from 1 to 6 of f of x dx. Then we want to subtract from that the integral from 1 to 6 of g of x. So that's 3, 1 to 6 f of x's, that's 4. Minus 1 to 6 g of x's, that's 8. 12 minus 8 leaves 4. So that's that. Oh, and these were the ones I said I don't care about. And I still don't care. I just don't. So kill those. Not doing those. I think that's it for homework 1. And since this video is at just about a half an hour, I'll just stop it. I'll do a second video for homework 1, and I'll push this one out to you guys now. Anyway, thanks for watching. See you Monday.